A load balancer is a device or software application that distributes incoming network traffic across multiple servers or resources to ensure no single server is overwhelmed with too much demand. The primary purpose of a load balancer is to enhance the availability and reliability of applications, websites, or services by optimizing the distribution of workloads. Here are the key functions and benefits of load balancers. 1. Distribution of traffic. Load balancers evenly distribute incoming traffic across multiple servers. This prevents any single server from becoming a bottleneck and helps ensure that all servers share the load. 2. Scalability. Load balancers enable horizontal scaling by adding more servers to a server farm. As the demand for a service increases, additional servers can be added to handle the load, and the load balancer ensures an even distribution of requests. 3. High availability. By distributing traffic across multiple servers, load balancers enhance the availability of a service. If one server fails or experiences issues, the load balancer redirects traffic to healthy servers, minimizing downtime. 4. Optimized resource utilization. Load balancing optimizes resource utilization by ensuring that each server in a cluster is used efficiently. This helps in preventing situations where some servers are underutilized while others are overloaded. 5. Improved performance. Load balancers can direct requests to the server that can respond most efficiently based on factors like server health, response times, and current server load. This leads to improved overall performance for users. 6. SSL termination. Some load balancers can handle SSL TLS encryption and decryption, offloading this resource-intensive process from the backend servers. This can improve the efficiency of the overall system. 7. Session persistence. Load balancers can ensure that a user's requests are consistently directed to the same server during a session. This is important for applications that require stateful connections, such as online banking or e-commerce websites. 8. Health monitoring. Load balancers continually monitor the health of servers by checking their responsiveness and status. If a server becomes unavailable or experiences issues, the load balancer can automatically stop sending traffic to that server. 9. Global Server Load Balancing, GSLB. For organizations with geographically distributed data centers, GSLB allows load balancing across multiple locations, improving performance and providing redundancy. 10. Centralized management. Load balancers typically offer centralized management interfaces, making it easier for administrators to configure and monitor the load balancing setup. Load balancing is a crucial component in the design of scalable, high-performance, and fault-tolerant systems, ensuring that resources are utilized efficiently and users experience optimal service availability and responsiveness.